Hi, this is Synthchaser from Synthchaser.com. In our last video, we started the repair of Don Lewis's original ARP Soloist, and we got it making some sound. I'll briefly recap where we left off. The key contacts are really dirty. Violin is out. Harpsichord doesn't sound like a harpsichord. The touch sensor effects don't work. So we're going to have to replace the sliders, troubleshoot a couple voices, fix the touch sensor effects, and clean the key contacts in order to get this keyboard fully working. I troubleshot the missing violin preset, and it's bad news. Some of the sounds like horns, cello, and violin are formed with dedicated resonators. On the Soloist, the resonators are encapsulated in these 4 submodules, which ARP called the voice modules. On this particular one, they're just a part number here, but on my older Soloist, it calls it like violin voice, cello voice, 3 voice module. Well, the 4030 violin voice module here is dead, and I'll show you. But first, let's look at a working one. This 4031 submodule is for the cello. The submodules take as input the sawtooth waveform here and a enable control line here. So I'll go ahead and turn the cello off, and you'll see that go low. Turn it back on, and it goes high. So there's a single pin over here which has the output. So if I turn cello voice off again, you'll see the output goes away. I turn it back on, and it's there again. So moving over to the 4030 submodule for the violin, let's find the sawtooth waveform. Sawtooth waveform is here. I'll turn the enable on, and then we'll go look at the output pin, and there's nothing there. So I have other videos where I've repaired ARP submodules, so we can just fix this thing, right? Well, wrong. The problem is this submodule is encapsulated in epoxy, and it's not possible to excavate it and repair it like I've done in other videos with the silicone potted submodules. To make matters worse, there's no schematic available of what's inside this submodule. I had to get gouged online just to buy a PDF of the service manual for the synthesizer, and all it shows for this module is a black box. So this would be the end of the line in most situations for most repair people. Even if the repair person could take it further, it wouldn't be cost effective to do so for the customer. But I'm not most repair people, and I'm doing this repair pro bono for the memory of my friend Don, so I'm not going to let something like an epoxy potted black box get in the way of fixing this synthesizer. So here's my idea. In the Pro Soloist, the concept of the mystery box went away, and they have the schematics published for the resonators, which they use for the violin voice. In fact, there's 3 resonators used to make the violin voice. On the Pro Soloist, violin is made with a pulse waveform, and the original Soloist is a sawtooth. So they're not going to be the same sound, but it's probably going to be close enough that I can use the Pro Soloist resonators in the original Soloist with some good results. I'd imagine I'll need to make some changes to account for different signal levels between the synthesizers, and I'm also going to need to implement the switching via the enable line. The Pro Soloist does this with open collector ROMs, but in the Soloist it's done with individual FETs, probably one of which is inside this module. So I see Don has modified some of the presets of the synthesizer. All these diodes here and here are used as a matrix for kind of selecting the routing of the signal. You know, whether you have an envelope with a long attack or a shorter attack, or high cutoff frequency to the filter or low cutoff frequency, whether you're routing something to the AR or the ADSR. So it looks like there's some diodes and resistors kind of soldered here. A little bit in the air though. Probably to change some of the presets to give it the sound that he was looking for. So as part of what I'm going to do is I'm going to change this back. I am going to look to see which ones he changed though. I wonder if that's why the harpsichord sounded more like a bass. Yeah, in fact, this one with the most modification action going on here as number 17, pin 17, and that is for the harpsichord. So I'm going to put it back to the way it originally was, and we'll hear what it sounds like. So I removed the diodes and resistors that had been added to change the feature routing matrix, and also I noticed there were a lot of diodes that had been cut. So I went through and looked at them, and then there were about 14 of them that had been cut. So I replaced them, and now our preset matrix should be back to factory presets, and our harpsichord sounds more like a harpsichord than a bass, so I think that's taken care of. These two jacks on the back turned out not to be connected to anything. The wires inside were actually disconnected from the jack, but it looked like they were coming from the touch sensor effects. So I noticed the touch sensors themselves are missing from the synthesizer, so it's possible that Don had created or was trying to create an interface to use something like a pedal to control the touch sensor effects. So taking a look at the Cinch Jones connector, it looks like it was used to provide some kind of external control over the Soloist's keyboard. So it's tied in here at the top on the keyboard electronics board. You can see in the back corner, the upper left, there's some extra resistors and a transistor and some wires kind of soldered in the air. That's the control voltage for the keyboard. It looks like a wire, this white wire in the front was cut, heat shrinked and routed to this cable. That should go down to this post under the trimmer where this disconnected orange wire is. That's the current source for the keyboard in the synthesizer. So that's kind of why when I'm pressing things, I'm not really getting any single note on the keyboard in here. So what I'm gonna have to do is I'm gonna have to take this the side panel off so I can get access to this board and revert this to its original state, and I can use one of my other soloists to kind of compare what it should look like. But right now it's kind of confusing because it was repurposed possibly to be controlled with an external keyboard or bass pedals from the Hammond organ that it was sitting on top of. So the internal keyboard's not really usable now. It looks like the repeat switch has also been disconnected or repurposed. There's some diodes there, cut wires, and the repeat function isn't working. So I've removed the modifications from the keyboard electronics board, all those wires that we saw in here. There was an extra circuit board that was rigged into that board, and then a whole bunch of component changes on the board itself. So it was a bit of a challenge and time-consuming to work through, but I've got it back to original now. I've also rewired the pots on the back that had been repurposed, and I've rewired the repeat switch, so now repeat will work. And the keyboard now is working. Before, it wasn't really making any definite pitch. It was just kind of floating around. Because like the keyboard current source was disconnected here on the keyboard electronics board, and it was going off to that modification. So now the key contacts are very dirty, but the pitch does increase as I work my way up the key bed. Of course, I'll need to confirm that it's calibrated correctly, that it's generating 1 volt per octave, and then of course we're going to need to tune the oscillator. But I think we're making good progress. So here I've breadboarded one of the 3 resonators that makes up the violin voice, as well as the switching. So if I go down here and turn off the violin, let me find the right switch. Turn off the violin, the output of our new voice module will go away. Turn on the violin, and this is what it looks like with one resonator. And the same resonator in the Pro Soloist, the output waveform looks the same. At this point, I'm pretty confident that if I build the other 2 resonators, the sum of the outputs is going to look like a violin sound, or is going to sound like a violin sound. So what I'm going to do now is I'm going to put this stuff into schematic capture software and design a circuit board. And I can play with the values of the components on there later to adjust for any difference in levels between the soloist and the pro soloist. I just was cleaning the flux residue off where I took the 4030 submodule out. I was like, oh, there must have been something on my cloth that was putting white stuff on the circuit board because it's all discolored there where I was cleaning. No, actually, this is all cigarette smoke residue from some of the different clubs that Don played in, built up on the bottom of the circuit board. It's all worked its way all the way down into the bottom of the keyboard, and that's what actually the circuit board looks like clean, and that's what it looks like now. Sometimes I see ones that are much worse than this. So I got my circuit board back and I've assembled it, and I put a little note there dedicated to Don Lewis. And I'm going to try it out now, replacing the original violin voice module. Overall, it went better than expected. I dropped it in and it wasn't working right, so I had to troubleshoot, and there was a problem with one of the component layouts that I had used in the schematic. So once I made a change on the board to account for that, now we have a pretty decent violin sound. I'll turn the violin off so we can hear that the enable switch is, the enable line is working on it. I'll turn cello on for reference so you can hear. So that's the cello sound, and that's the violin sound. So I would call this a success. We've got a violin sound coming from it. May not be exactly the same as the original soloist's violin sound, but that's because they never published these schematics and they encased them in epoxy, so no one could figure out what was going on. And unfortunately, the original designers are all gone, so we got to make do, and I think we did great. So I'm going to replace the tantalum and electrolytic capacitors in the keyboard. The electrolytic capacitors are past their prime at this point. It's over 50 years old. And the tantalum capacitors are prone to short out. A couple of the other soloists that I was working on in parallel with this one had some shorted tantalum capacitors. So as a preventative maintenance, those will get replaced. Also, we need to do something about the sliders. You can see here this is the only one with an original slider shaft. This is maybe a different type of slider or shaft, and these are folded over cocktail straws. So I'm going to replace those sliders with new ones and give them the appropriate slider caps. But we're going to start with the power supply. Nothing on this keyboard is easy to work on, and getting to the power supply is no exception. To get to the power supply, we actually need to take this right portion of the keyboard off. And to do that, we have to take the top and front panels off, then actually detach that part from the frame inside. I'll show you what I mean. So with the little front plate and the top panel off, now I can get access to the screws here to remove this side with the power supply. You'll notice that the toggle switches here are actually riveted to this frame. This one isn't Don's, but if you ever work on one of these, hope you don't have to change one of these switches, because they are riveted to this frame and then all interconnected with the wiring. They did not make this keyboard with any thought of serviceability. So now I've unscrewed this from this frame, and I can go ahead and disconnect this cable, disconnecting the keyboard from the power supply, and now I have access to the power supply, sort of, but not quite yet. So the issue is you take the panel off the other side to gain access to these screws, but you can't work on the board with it in there because the traces and pads that you need to solder and desolder are tucked under this metal panel. So we got to take the panel off to access these screws, and then we'll be able to free that board. We won't be able to remove the board because it is hardwired to the power transformer. Well, there's a connector that goes to the rest of the keyboard, but not to the transformer. So let's get that freed up. And to make it as big of a pain as possible, the screws are on the bottom, but you have to hold the nuts so they don't just spin freely. And they are way back here in a difficult to access location. Really terrible layout of this keyboard. And now I've finally got the circuit board freed, and I can desolder and replace these power supply components, the tantalum capacitors that are prone to shorting out, and the past their prime electrolytic capacitors that have a date code of the 39th week of 1971, which at the time of making this video is 51 and a quarter years ago. They really love their rivets there at ARP. It's not like anyone would ever need to change the pass transistor in their power supply. So let's permanently affix it to this heatsink. Let's also not mark the polarity of any of the capacitors on this board. Before I put this back together, I can test both power rails without load, give it a rough calibration to make sure that it's not over voltage. I'd expect the voltage to change a little bit once the load is connected, so I'll need to recalibrate it when I'm done, but I can go ahead right now and just give it a little adjustment to dial it in to a reasonably correct voltage. And I can do the same for the minus 15 rail. There we go. So now this part is ready to go back onto the frame. While I had the top panel and the front panel off, I cleaned the panels up a little bit, and I also cleaned the keys. So next up, I'm going to change some capacitors on the keyboard electronics board. I already had this board out to revert some modifications to it, but I didn't change the capacitors at that time. Now I'm going to go back and do that. To get to this board, I have to take the side panel off and then unscrew it from the panel. The purpose of this board is to basically control the key bed and generate a gate, trigger, and keyboard control voltage for the rest of the synthesizer. So now I freed the board so I can get to the back side and solder and desolder the capacitors, but the wires to the other boards are hardwired in there, so I can't remove the board. So you may be wondering, why didn't you change those capacitors when you had this board out to revert Don's modifications? And the answer is I didn't want to introduce any more variables than I had to. I was trying to get the synthesizer to a working state and just trying to get it back to its original condition. And I didn't want to add more variables because that can complicate troubleshooting later if that became necessary. So now that we've got the keyboard working, now I'm going to go through and do that kind of preventative maintenance that could have complicated things if I did it earlier. So next up is this board with the touch sensor effects and the sliders. And this board is actually on some hinged supports, hinged standoffs there. So you're supposed to remove these 3 screws and then you can fold the board up. But I find the board, it doesn't fold up enough for you to really work on it. And then it's immediately flopping back down. So I'm just going to take these screws out as well, and that way I can get to this side of the board, or I can put it up here and get to the other side of the board. Okay, so I've got the board flipped up here, and we can see that there's some tantalum capacitors hanging out around this board that we're going to need to replace. And then the sliders. You'll notice that the sliders look like ARP 2600 sliders. I'll grab a replacement slider. So they look like ARP 2600 sliders, except the shaft. This is the broken shafts. These are all broken. This is the only one that's got a complete shaft, and the shaft is longer than the one on this. So what we're going to do is we're going to install some spacers that I've 3D printed that will go under there and raise this to the right height, so when we put the slider cap on, it will be seamless looking from the outside of the synthesizer. But yeah, I don't have I have replacement shafts for the ARP 2600, but they would be too short to do us any good. So it might be hard to see it, so I'm kind of going on an angle, but you can see the factory soldering are these soldering joints are these huge blobs, way too much solder on the joints. So I don't know what they did, but yeah, that's not good. So the capacitors and sliders are changed on this board, and from the outside you can't tell what we had to do to get the sliders to be the right height. And that leaves just a handful of capacitors, like here and here, there, that we're going to want to change on the remaining boards. There's still a lot more work to do on Dawn Soloist, but this is where the video series is going to end. I'm doing this work pro bono to begin with, and there just doesn't seem to be enough interest to justify the extra time to continue the series. I will leave you with a few takeaways. First and foremost, Don Lewis will be missed. He was a brilliant mind, and his smile and positive attitude was absolutely infectious. Second, if you don't know Don's story, you need to get a DVD of the Ballad of Don Lewis. Even if you've never heard of Don, I'm confident you'll find this documentary about him time and money well spent. Third, I think this is my 160th Synthchaser video. Of all of them, my personal favorite is number 130. In most of my videos, I'm all sad and lonely by myself in my workshop with my soldering iron and some keyboards. But in this one, number 130, Don came and joined me, and we talked about his live electronic orchestra system, and then we worked on it together. That video was so fun to make, and I had such a good time with Don. If you haven't seen it, check it out. Finally, if you find yourself near Southern California, take a trip to NAMM's Museum of Making Music in Carlsbad. Leo is on exhibit there, and it's an amazing sight to see in person. I'm Synthchaser from synthchaser.com. Thanks for watching, and have a great day.